Hi, welcome to the second segment of Lecture 2 on descriptive statistics. In the second segment, we're going to take the opposite approach of what we did in the first segment. We're going to now focus in on our data and get some summary statistics, basically as talking points to tell people what's going on in our data. So the important concepts to take away from this segment are measures of central tendency, measures of variability, skew, and kurtosis. And remember, those are the 4 moments of the mean. Again, we're going to go wine tasting. I'm going to use the same data that we used in the first segment, where we assume that 30 wine experts rated the overall quality of 4 different wines on a scale of 1 to 10. And 10 is highest quality. I'm using the same exact data here. Okay, so remember, for Whoop Whoop, we had a uniform distribution. Red Truck, we had a normal distribution. Hobnob was positively skewed. Foreplay was negatively skewed. And you can see that best in the density plots or smoothed histograms. But I probably wouldn't want to present density plots to a marketer or an advertiser or even the owner of the winery. Right? They would want just some summary statistics. Which wine did they like the best? So we could calculate the mean rating for all the wines and see which one did the best. So that's the idea behind summary statistics. So I took these data that I just simulated in R and I ran them through the describe function in R. So this is actual output from my R script, and in the next lecture I'll show you how to do this. So in R, any piece of code that starts with the pound sign, so here the pound sign, any line that starts with the pound sign is just a comment. So I just wrote a comment saying, here are the descriptive statistics for the variables in a data frame called ratings. So ratings is just a variable that I made up in R. Describe is a function in R. So it takes the ratings and it applies the describe function. It then gives us all this output. So it organizes the variables into rows. So we have Red Truck, Whoop Whoop, Hobnob, Foreplay. They're numbered, variables 1 through 4. The N refers to how many raters there were, so how many observations do we have per wine or per variable. And then we get a bunch of descriptive statistics, okay? Actually more than we need for our purposes right now. So let's just focus on a couple. First, we have the mean, right? So that's a measure of central tendency. And you see that, let me get rid of those. You see that the mean for Red Truck was 5.5, the mean for Whoop Whoop 5.5. Hobnob, again, was a little lower, right, because it had a positive skew, and Foreplay a little higher because it had a negative skew. And the next column is standard deviation. That's a measure of variability that we'll talk about in detail in a moment. The next one is the median. Again, a measure of central tendency we'll get to in a second. Then R presents several other descriptives. So trimmed refers to a trimmed mean. Again, a measure of central tendency. MAD is the median absolute deviation. That's sort of an obscure statistic that's pretty unique to R. It's sort of like the standard deviation. It's on the same it's a measure of variability. And then you have the min and the max and the range. Again, those two are giving you measures of variability. And then finally, skew and kurtosis. And let's not worry about SE just yet. That stands for standard error. We'll get there next week. Okay, so let's talk about first measures of central tendency. So a good measure of central tendency just describes the center point of a distribution. It should be representative of the distribution. And hopefully this is review to you, but if not, take the time to go through this. The most common measures of central tendency are mean, median, and mode. And by far the most common is the mean, or the average. We're very used to taking the average of a distribution of scores. Most common is your average grade point average, or your grades in school. And the way to do that is just to sum up all your scores and divide by the number of scores. So that's what I'm saying here. By the mean equals the sum of x divided by n. The median is a little different. It's just the middle score in a distribution. So if I just lined everybody up from highest score to lowest score and just plucked out the middle person in the line and asked them, what's your score? That's the median. The mode is just the score that occurs most often. So as I said, the mean is the most common measure of central tendency that we'll use and that you'll see reported in the social sciences and natural sciences. Good examples are average grade point average, average SAT for different classes or different groups of people, and again, the average wine ratings in our example. There are some cases, though, where we won't want to use the mean, especially when we have a high degree of skew or a few very extreme scores in our distribution. We might want to use the median instead of the mean as our measure of central tendency. That's because the mean is influenced by those extreme scores, because it sums all the scores together, right? Every score gets to contribute. So if there's one extreme score, it's really going to throw off the mean. A good example of that is the first one here on the slide, median household income. That's one you see reported a lot in the news or in the newspaper, because average household income is biased by extreme incomes like Bill Gates, right? So imagine I just randomly selected 10 people and I just happened to get Bill Gates in my random sample of 10, and I calculated the average household income for those 10 people. If Bill Gates was in there, it would be a huge number and not representative of the other 9 people, most likely, right? So in that case, it would be better to just line them up from Bill Gates down to the person with the lowest household income, take the middle person, and take their income as our measure of central tendency. That's the median. You might make a case for using the median for your GPA. I've never seen this done, but I would be happy to see it done, because sometimes that is a better representative or more representative of your overall performance, particularly if you have just 1 or 2 really poor grades and the rest are A's and B's, right? Then the median might be a better measure of central tendency. The other example I have in here is reaction time, because as I said, I'm a cognitive psychologist. We do experiments where we have people working on a computer, and we often want to measure how fast they respond to stimuli on a screen. And those distributions are notoriously positively skewed within an individual, because on some trials, just moment to moment, people space out, they might look away from the computer, they're distracted. So a few of the reaction times are extremely long relative to the rest of the distribution. So that's a common one in psychology, is we often look at the median reaction time, or we try to transform that distribution somehow to make it more normal. And last, the mode is just the score that occurs most often. We're not going to see this a lot in inferential statistics, or probably much in this course. Just know what the mode is. It's real easy to spot if you're looking at a histogram. It's just the peak of the histogram. You could think of it as the most popular score. And again, you could try and use that for GPA. You could say, I mostly got A's. If that was the grade that you got the most, that was your mode. You could use that as your measure of central tendency for your school performance. The next type of summary statistic we're going to look at are measures of variability. So what's the diversity and range of scores across the distribution? and think of the histograms, like how wide was the histogram? The two important concepts here, and these are really critical, we're going to use these throughout this entire course, are standard deviation and variance. And standard deviation is just the square root of variance. And we're actually going to walk through this because it's important that you know this formula just as well as you know the formula for a mean. And again, I'm hoping that this is review for most of you. If it's not, take your time to work through it. And I know from teaching this course for many years that some students just have a hard time embracing this concept of variance. It's just hard to wrap their head around. And often in psychology, in particular, variance is portrayed in a really negative way. Like the intelligence example, people don't like to think about the fact that, well, there are some people down at the bottom end of that distribution and there's all this variability. It's inequitable. Same as household income, right? So sometimes in psychology and the social sciences, we think of this variance as being bad. But from a statistician's point of view, and I'm hoping that you can embrace this point of view, variance is great. It's information for us, and it's going to be very useful. And to just reinforce the idea that variance is good, just go back to the work of Darwin, right? It's an essential part of the theory of evolution. So you're probably most familiar with The Origin of Species, but Darwin actually wanted to say even more in that book about the importance of variation within and across species. And so he was forced by his editor to leave some of it out. So he wound up publishing a second book. Well, he published several books, but another book specifically on variation and its importance. So try to embrace variation and variance as a good thing and as a source of information. And to demonstrate this concept, I'm going to use a professional basketball example. So if you're from the United States, even if you're not, you might be familiar with this. This is a basketball player named Jeremy Lin. Last year, he played for the New York Knicks, and he went on a run of scoring lots of points. And in New York City, where I live, it was Linsanity. And that was the term that was used all over the newspapers. And there he is in Madison Square Garden. So wherever you are in the world, I bet you've heard of Madison Square Garden. That's the roof of or the ceiling, I should say, of Madison Square Garden, right in the middle of Manhattan, right near where I live. So I was caught up in Linsanity. So let's look at Jeremy Lin's points per game over that time when New York got caught up in the frenzy of this relatively unknown guy suddenly becoming one of the best players in the league. So what I've done here is I've just listed his points per game, and I actually started down at the bottom. You can see there's just he scored 2 points in one game. That was the game just before the star for the Knicks, Carmelo Anthony, was injured, which allowed Jeremy Lin to get more playing time. So you see, he was scoring hardly any points at all. He sometimes didn't even get in the game. But then once he got in the game, once he started, he scored 25 points, then 28 points, then 23, then 38. I was just using this example recently in class, and one of my students was at one of those games. It was in Dallas, he told me. I can't remember which, the 23 or the 38. That's right around when people started to take notice of this guy, Jeremy Lin. So what we can do is over these 10 games, we can calculate his average. What was he averaging in those 10 games? But we can also look at his variability. Was he consistent in his points per game across that period, or did he vary a lot? So the way to do that is first get the average, get the mean, and I've done that in the first column, so just sum all the scores and divide by n. So the sum of the first column is 227. There were 10 games that I'm considering here, so his average during that time was 22.7. The way to get at variability is to look at each individual game and compare it to his average. So how much for each game was he deviating from his average? So what we do is take the individual score x and subtract the mean. So that's the second column, and that's called the deviation score. Just tells you per game how much is he deviating from his mean. You see this big deviation score down here because that's when he wasn't starting, he wasn't getting much playing time. Then what we want to do is square all the deviation scores, because we can't just take the average of the deviation scores, they sum to 0. So let's square them and get rid of sign. Then we can sum the squared deviation scores and divide by n. So if we sum this column, we get 922.1 divided by 10 is 92.21. That is variance. And another term for variance is mean squares, because it's the mean of the sum of squares. So these are the results. His average was 22.7. His standard deviation was 9.6. That's high, right? He wasn't really varying that much game to game. It's just because we included that 2 in there. And again, start to embrace this notation. This is going to be very common, and we'll use it a lot as we move forward through the course. I'm going to use this phrase mean squares for variance. So they both mean variance. Mean squares and variance, same thing. And again, it's right there in the math. You should feel comfortable with this mathematically. It's the deviation scores, square them, sum the squared deviation scores. That's the sum of squares. If you divide by n, that's the mean squares. Okay, so sum of squares, mean squares, that gives us variance. Take the square root, and you're back in the units that you started in, and that's standard deviation. So we could look at Jeremy Lin over those 10 games and say, whoa, he went from being a nobody to being one of the best players in the league, at least in terms of points per game. So let's compare him to a player that we know is genuinely one of the best in the league, Kobe Bryant. So what I did is, over that span of time, I just took 10 games from Kobe Bryant, and I got his statistics, and then I plugged them into R, and I got descriptives. And if we look at the 10 games, then we see Jeremy Lin wasn't really up to the level of Kobe Bryant. All right, Kobe was averaging 26.4. Jeremy Lin was averaging 22.7. Not quite Kobe Bryant. But what if we eliminated that 2, because he wasn't starting in that game? What if we just looked at those 9 games? Then he was almost up to Kobe Bryant's level in terms of points per game. Also, in terms of variability, right? So he was just as consistent as Kobe Bryant over that span of time. Hence the Linsanity. Unfortunately, it ended and he was traded to Houston. And the Knicks went nowhere. So it's a sad story in the end. So to review, the summary statistics that we'll focus on here are measures of central tendency, measures of variability, measures of skew, and measures of kurtosis. Central tendency will typically rely on the mean or average. Sometimes we'll use the median when we have extreme scores or skewed distributions. And with variability, make sure you know standard deviation and variance and how to calculate those. So just to reinforce that, these are the formulae that you should just know going forward. So these could be on quizzes. You should be able to retrieve these. I'm hoping this is certainly review for everyone. Just the mean is summing up all the scores dividing by n. But then make sure you know how to get standard deviation and variance just as easily as you can calculate the mean.